For those of you listening at home, hi. Just missed the first 30 seconds. We went over the very first shape we did yesterday, 30, 60, 90 degree triangle, 30, 60, 90 degree. And the sides are 1, 2, radical 3. Small, large, medium. Small across from small, medium across from medium, large across from large. Now, Michael, what is the next shape?
45, 45, 90 degree triangle.
Yes. 45, 45, 90 degree triangle. Can you give me the sides? Here's 45 degrees. Radical 2 is 1. 1 and 1. Oh dear, something's not okay. I feel very good. Anyway, number 3. What is the third shape? Yeah. Unit circle. Okay. There are 4 things you need to know about the unit circle. What's point 1? Jack Black. Give me one of the 4 things you need to know about the unit circle.
Well, there's a circle.
True. Where's the center?
0, 0.
Yes, that's one of them.
With a radius of 1. The
Okay.
angle is theta.
Okay, radius of 1, angle is whatever theta above or below.
Well,
Below. And most importantly, what? One more piece of info.
oh, the point is cosine theta and sine theta.
Correct. The point, the mystery point here is cosine of theta, sine of theta. Cosine is left, right. Sine is up, down. That's pretty much where we left off yesterday. I want to talk just a little bit more about that. If I surgically remove this triangle, this right triangle, if I drop this down and make the right triangle, this would be the dominant side. This is y, this is x, because I had no idea how big those are. This is x, and the height is y. And this is 1, so x, y, and 1. Here's theta. Just by playing with the trig functions, we found that the sine of theta was opposite of our hypotenuse, which turns out to be y. We were looking for this mystery point xy. We just found one of the parts. Y is equal to sine of theta. And just by, again, this is sort of by accident. We're just playing with trig. We had no idea this would come up with anything useful. The cosine of theta is adjacent over hypotenuse, which is x over 1, that are known as x. And we have just discovered the other part. X is cosine of theta. There's one trig function we have not tried yet. Which one is that, Sophie? Tangent. Can somebody tell me what you would get if you tried tangent? So go ahead. Y over x. Now, that doesn't simplify algebra-wise, but what did we find out that the letter y was equal to? Sine of theta. Because we found out that y and sine of theta were equal. What did we find out that x was? You have just discovered one of what we call the master formulas. We did not really talk about this last year. We're going to talk about it quite a bit this year. But one thing we discovered is that tangent is equal to sine divided by cosine. Every single time. Grab a calculator. If you don't have one, there's a few stacked up on the end of the table there. But take out your calculators. I'm going to show something. Hopefully you're still in degree mode. If you don't know how to switch your mode, talk to me. For now, I'm just going to pick a random angle. So example, can somebody tell me the sine of 10 degrees? Approximately. So give me 4 decimal places. Let's see who's fast on the fingers. Yeah.
0.1736.
Yeah, 0.1736, more or less, blah, blah, blah. Can Can somebody give me the cosine of 10 degrees? Give me point something. 0.9848, yeah, roughly, 0.9848. Blah, 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 blah. Can somebody give me tangent of 10 degrees? And by the way, if you know your way around the unit circle, you can actually take educated guesses as to how, I mean, there's no way I would have gotten that in my head. Like, oh my goodness, it'll be silly. But I knew, like if I went up to 10 degrees, I knew sine is height. The sine of 10 degrees can't be very big. It's like, if this is 1 inch, how big is this? Maybe a quarter inch or something like that, which is not too far away, 0.25, a little less. And I could have made an educated guess. Cosine is how far over it is. 10 degrees is pretty far over. So it's not all the way over, it's not 1, but it's pretty close to 1. And yeah. What is tangent of 10? Let me get it. What do you get? Yeah.
0.1763.
0.1763. Now, don't fool that with the sine of 10. They're not the same. 6.3 and 3/6. Good question. Can somebody take the sine of 10 degrees and divide it by the cosine of 10 degrees? Just on your screen. Sine of 10, close the parentheses. Divided by cosine of 10, close parentheses. Tell me what you get. If you have lots, yeah. 0.1763. By the way, I got 0.1763269807. And interestingly enough, I got 0.1763269807. Notice something? Right down it goes. Any angle on Earth, the tangent is always equal to the sine divided by the cosine. So let's just say, you know, your little brother or sister decides to play with your calculator and break the tangent button. Now, first of all, don't kill them, even though you might feel like it. And yeah, they destroyed a beach and a half property, which would make even the most calm person angry. But there's a way around it. How am I going to do this? Darn it, I needed to find the tangent for the trig test. You can do sine divided by cosine. Save it. I'm sure that happens all the time. But you get it? There's one other thing about that. It's from algebra. Well, a little bit of geometry too. If I square this off, and no pun intended, and make a rectangle, how long is this? A minute? Oh. If I make this a perfect rectangle, how tall would this have to be? What? How long would this have to be? X. Do you notice this is rise and run? Y over X is rise over run. Guess what you just found? What is rise over run? What's that? True. Go back to first year algebra. What's the definition of rise over run? That finds the what? If you're graphing the slope. You've just found something else. The sine of theta, this is on the unit circle. You may want to write this down somewhere. It's a summary of what we've learned so far. On the unit circle, sine is how far up or down it is. It's the height. Cosine is how far side to side, or left to right. Tangent is equal to the slope of that radius. That's guaranteed. If you find the slope, you found the tangent. If you found the tangent, you found the slope. I remember a problem like this. Again, I have not memorized every single problem that I messed up in high school.
There's memorized a lot.
Because I messed up a lot in high school. I'm trying not to be bitter about it or anything, but if I gave you an angle, like here's a line and it causes a 62-degree angle. Tell me the slope, approximately. I had absolutely no idea. I fought with this thing for like 15 minutes. I made right triangles, I did blah, 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 I had no clue. It's really so easy. How do you find the slope? It's the same thing as what? Tangent. Tangent of what?
M, so 62.
Let's try it. Tangent of 62. Oops, it helps if I turn on calculator. I've got 1.8807. Done. The slope and the tangent are identical. The slope of the tangent and the tangent of the slope, they're identical. Does that make sense about it? So this is probably the most useful thing we've learned so far. On a unit circle, cosine means how far left or right you are. Sine is how far up down you are. Tangent is what the slope of the radius is. Now, yesterday, I warned you that there are a few of these sine, cosine, and tangent problems that you have to use a calculator. Like sine of 10 degrees, I don't know if anybody can get that in their head, or on paper, frankly. But maybe you could get something else. Could somebody find me, for example, the cosine of 30 degrees without a decimal? Maybe we did this yesterday. How do you do it?
Well, you have to memorize the 30, 60, 90.
Correct. Let's assume you have.
And then, so cosine is adjacent over hypotenuse.
Okay. And if you're on 30 degrees, tell me the fraction.
Radical 3 over 2.
You got it. Got it. That's an actual number. If you type this into a calculator, you get approximately 0.866 something. It's just we don't know it. But that's radical 3 over 2. It's the positive square root of 3 divided by 2. It's an actual number. Does that make sense? What do you need to know about all this? First, you need to know the three trig shapes so far. 30, 60, 90 degree triangle, 45, 45, 90 degree triangle, and the unit circle. For the 30, 60, 90 degree triangle, you have to know that the sides are 1, 2, radical 3. Small, large, medium. You could do 1 radical 3 too and do in order. It just sounds better with 1, 2 radical 3. 45, 45, 90 degree triangle, you have to know that it's 1, 1, and then the largest side is radical 2. Unit circle, you have to know 4 things. The center is 0, 0. The radius is 1. The angle is theta underneath. And then the coordinates of the point are cosine of theta, comma sine of theta. That's what you'll need to know on the test. And that's what you'll need to know in order to make all of the problems in this chapter work. Okay? Now, on the unit circle, if you know that the sine of this angle gives you the height of the point, cosine gives you how far over the point is, and tangent gives you the slope, that gives you a lot of power. Let me give you an example. By the end of this week, you're going to be doing some fairly intense problems on this. And by the end of next week, you'll be doing them so easily that you'd be amazed that you ever struggled with them. There's good news and bad news on the point. The bad news is you do have some stuff to memorize. The good news is once you memorize, and it's not all that much, the homework becomes arguably 8 times faster. I didn't actually sit down and measure it, but it was really, really fast. Like an hour's worth of homework can be done in like 10, 15 minutes. Probably 10. Actually, that's 6. Maybe 8 minutes. Let me show you what I mean. Draw, if you will, everybody, draw a unit circle. You're going to be drawing like 200 of these by the time you're done with this chapter. The unit circle is centered at 0, 0. And I'd like you to draw a radius at the 30 degree mark. Can somebody refresh my memory of the sine of 30 degrees? What do you think? Pete, how do you get sine sine? Opposite or hypotenuse. Is there a triangle where you could do that? For 30 degrees.
30, 60, 90 triangle.
Yes. How far does a 30-degree angle? Do opposite and hypotenuse. What do you get as a fraction? 1/2. On the one hand, you just got sine of 30 with SOHCAHTOA. On the other hand, can somebody refresh my memory? What does sine mean on the unit circle? Michael. Up, down. That means how high it is. I'm going to draw the height of that 30 degree. Can anybody guess how high that actually is? Let's pretend going all the way up is like 1 inch high. How high is this? I mean, that's less than 1, but
Would it be half an inch?
it's 1/2 of an inch. How do you get that?
Because it equals 1/2.
Yeah, the sign tells you how high up it is. That's exactly what they're talking about. So the sine of 30 is 1/2. The height of 30 degrees is 1/2. Does that make sense? Is it visual? Can somebody refresh my memory on the cosine of 30 degrees? You hand it's on the board. Julie Sishan, what's the cosine of 30 degrees? Radical 3/2. And I'll give you a decimal approximation. It's 0.866. Blah, 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 blah. Can anybody tell me how far over this is? Roughly? How much distance over? It's less than 1. Not much less than 1. But it's a little less than 1 because it's not all the way to the edge. So, Polly, how far over is that?
Is it over radical 3/2?
It is over radical 3/2. As a decimal, what is that approximately? 0.866. So it's a little less than 0.9. It's a little less than 9/10 of an inch. In other words, it's most of the way over. You see that? Ever see visually? Sine is how far up it is, and you can just find that. Cosine is, that's how far up it is. Cosine is how far over it is, and you just found that. Can anybody tell me the tangent, the slope of this line? The angle at which it's tilted is 30 degrees. Can somebody tell me the slope? We do not know the rise, we do not know the run. This is not 1 and this is not 1. So I have no idea how to do it with regular slope. But can somebody find it using a trick? Sophie, how do you find tangent? Oh, I hate it when I do that. How do you find slope?
Tangent.
Yes. So how would you do this?
1/2 over radical 3/2.
Oh, clever. By the way, that's true, by the way. You can do sine divided by, let's do that. 1/2 divided, I wasn't even going to do that. That was the super clever way to do it. I was just going to do tangent with SOHCAHTOA. But let's try it. How do you divide fractions?
Multiplying by the reciprocal.
Yeah, times 2 over radical 3. What do you get?
2 over 2 radical 3.
Yeah, what happens to the 2's? What do you get?
1 over radical 3.
And then get the radical of the basement for me.
So multiply by radical 3 over radical 3.
Okay?
And then you have radical 3 over
What's radical 3 times radical 3?
3.
The number 3. You've just found the slope, which, by the way, is also the tangent of 30. It's 1 over radical 3, which, if you get the radical of the basement, is radical 3 over 3. I would like this as an answer on the test. Radical 3 over 3. So, this, by the way, is very clever. You could have gone over here and done tangent, which is opposite over adjacent, and got the same answer. But the sine over cosine is sneaky. Keep that in mind. So next. So what's it on? Because I'm about to throw you a curveball. Can somebody tell me the sine 150 degrees. Yeah.
Well, I don't remember exactly how we did this last year, but, so it's just a factor of 30.
True, it's a multiple
right?
30.
Multiple 30.
Uh-huh.
So, can't you just base it off that?
You can,
Something like that.
depending on how. Now, does everybody see that if I tried this with a triangle, we'd have serious problems? Here's what I try to do. So here's it's got to be a right triangle, and you're trying to do 150 degrees. Does anybody see a problem with this? I hope, yes. Julie, see some, what's the problem? Yeah, you got way more than 180, you haven't even used the third angle yet, and this is a totally illegal triangle. You've got 240 degrees already, you've already killed your triangle, and you still have one more angle to go. So I can't use SOHCAHTOA. I can't use opposite over adjacent, or opposite over hypotenuse, or adjacent over hypotenuse. Can't do any of those. In this case, opposite over hypotenuse. Polly, what was sine on the unit circle?
It's up down.
Up, down. That's how far up, right? What was the sine of 30 again? 1/2, that's how high up it is? Can you tell me what angle this would be? If you go all the way over here. Halfway around the circle is 180, if that helps. Where's this? If this is a perfect mirror image. Anyway. Like this is 30, 60, blah, 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 all the way up to 360. Where's this? If it's a perfect mirror image, go ahead. 120 would be up here. This would be 90. This is 30 degrees up from 0, if that helps. Go 30 degrees up from 180. It's 150. What's the height at that point? No, you're right the first time. Negative would be going down. So we just turned it with height. How does the height at 150 compare with the height at 30? Just for something. It's the same. You notice they're the exact same height? If the height here is 1/2, guess what this is? So 1/2. You've just found the sine of 150 degrees. If you can find an easier one, you can find the harder one. If you have something where they're both on the same height, they both have the same sign. S-I-N-E.
What do you do if it's like 240?
Good question. Let's try 240. Get this out of here. I'll assume at this point you're relatively comfy with the 30, 60, 90, 45, 45, 90 triangle. 240 degrees. I want to ask for the cosine of 240 degrees. Now, does everybody see that I cannot use a right triangle? Trying to use 240 degrees would explode it even worse than 150. There's only one shape that can hold something this big, and that's the unit circle. The unit circle can hold anything from 0 to 360. You can even go bigger if you go beyond, if you go like twice around or something like that. Where is 240? Can you tell me physically where it is?
It's
What
so
quadrant?
180 is on the left
Okay.
side of the axis there, and then you go 210 and then 240.
Correct. So it's 60 degrees down. So I have 60 degrees to go down there. So it's 240. I want to know the cosine. What does cosine mean on a unit circle?
Or from left to right.
Left, right. It's how far left to right. So what I want to know is how far left to right that is. The very first question is, can somebody tell me if the answer is going to be positive or negative? Michael. It's negative. Why do you say that? Negative something. This is quadrant 2. Quadrant 3. Well, what does quadrant 3 have to do with it? Why is cosine down here negative? Right. But is cosine up, down, or left, right? You're going to the left. That's negative. If I were on the right-hand side of the circle, the cosine would be positive, because you're going to the right. If it's on the left-hand side of the circle, then cosine would be negative. Can you make sense? Negative what? Well, and this is an open question to anybody. I don't know. I haven't the foggiest idea. But here's a little trick, and this is actually going to help you out with what we call the fourth trig shape. Do me a favor and draw a rectangle. Just go straight up, straight across, straight down, straight to the right. What? These are mirror images. In other words, this is the exact same distance over, because it's a perfect rectangle. It's got to go the same distance left as it goes to the right. So Noah, help me out. What position, degree-wise, is this?
So that's 30 minus 30 plus minus is 120.
120. There are two ways to get that. You can either, this is 270 down here.
Yeah.
You can either go 30 degrees back, or you can go 60 degrees up or down. Does that make sense? If you take 180 and go back 60 degrees, it should work also. Now, I still don't know what the cosine of 120 is. Where's this? Do this one. It's 60. How to get that, by the way? Yeah, it's 30 either way from 90. Question, can anybody tell me the cosine of 60? That you should be able to do without a calculator. Cosine of 60. Yeah. It's a half. How to get that?
Well, you could use your Bernoulli's triangle.
Correct. If you have, okay, there's 1, 2, radical 3. Here's your 60-degree angle. How do you get cosine again? Adjacent over hypotenuse. So question, they said that the cosine was 1/2, positive 1/2, right? So if we take over, if this is over positive 1/2, how far over is this? Negative 1/2. Can somebody tell me the cosine of 120 degrees while we're at it? I know.
The cosine of 120. It's the same.
No, what's the cosine here? Cosine up, down, the left, right, or slope?
Left, right.
Left, right. Is it to the left or to the right?
Left.
So is it positive or negative?
Negative.
Negative what?
1/2.
Negative 1/2. Can somebody tell me the cosine of 240 degrees now? Positive 1/2 doesn't go to the right. You got it. It's the exact same far overness as 120. The cosine of 120 and the cosine of 240 are identical. They both moved over the same amount. You just found a problem. Now note, you notice we had to go all the way back to the nicest possible mirror image. Like there are 4 different corners, and we went to the smallest one. Please write this down in your notes. This special angle is called a reference angle. The reference angle, which is rather important, is the mirror image angle in quadrant 1. When you draw that rectangle, one of the 4 corners is always going to be in quadrant 1. That's the one we want. That's called the reference angle because we refer back to it. That's the one where you can get the sine, the cosine, and the tangent easily because it's small enough to fit into a SOHCAHTOA triangle. We can do it by hand. These other ones are way too big. But if you refer back to the small small one. You can use, if this is over 1/2 to the right, then I guarantee you this is over 1/2 to the left, 1/2 to the left. And I can even tell you the cosine of 300. You want me to tell you? What's the cosine of 300 while we're at it? Have we got it? It's 1/2, positive 1/2. It's the same far overness as 60, so it's got to be the same cosine as 60. You seeing visually how this works? It takes a little getting used to, especially when you switch back from sine to cosine to tangent in the middle of the same problem. Just remember, cosine is how far over you are. Chances are, if I say, I'm thinking of an angle that has a cosine of 1/2, chances are there will be 2 angles over there. If I go over 1/2 of a space, 2 angles, like one on top, one on the bottom, gotta be there. If I'm saying, I'm thinking of an angle where the sine at the height is negative 1/2. It's gonna be down here. You see there'd be 2 of them? One here somewhere and one here somewhere, where they're on level with each other. The sine is how far up or down they are, the height. So if I say the height is negative 1/2, go down 1/2 and see how many angles there are. They're gonna be 2. Where are they? We'll find out in a minute.
Will the tangent be negative on quadrant 2 and 4?
Correct. The tangent is the slope. So if you want to, what is a negative slope? What does it do?
It's multiplied by -1.
Right, and what direction does it go?
This way.
Yeah, it goes downhill. So if I go downhill, that's a negative slope, which means a negative tangent. Anything in quadrant 2 and quadrant 4, where we have a downhill line, will have a negative tangent, a negative slope. In these 2 quadrants, where it's going uphill, if you have a positive slope, you can have a positive tangent. Positive what? I don't know. We'll find out later. You get the idea, at least visually? Sine is how far up or down it is. Above is going to have a positive sign. Below is going to have a negative sign, S-I-N-E. Cosine is how far over you are left, right. To the left is negative cosine. To the right is positive cosine. Tangent is your slope, whether it's uphill or downhill. Let me click these together, maybe I can do this. Yeah, that's not too bad. If it's uphill, you have a positive slope. So positive slope in quadrant 1 and quadrant 3. And if you're going downhill, you must be in quadrant 2 or quadrant 4. Okay. How do you find the actual slope? We'll find out in a minute. But do you see visually what sine, cosine, and tangent mean on the unit circle? And if we can find the values for 60 degrees, you can also find them for all the mirror image corners. It's time for me to show you the 4th trig shape. The first 3 trig shapes, 30, 60, 90 degree triangle, 45, 45, 90 degree triangle, unit circle. Here's the 4th. It's called the trig rectangle. And it looks like this. In order to draw a trig rectangle, you have to draw a unit circle first. So you have to draw all 4 parts. That means you have to know the 4 parts. The center, 0, 0. The radius is 1. The angle is theta underneath. And then the coordinates are cosine of theta, sine of theta. That's a unit circle. We have not drawn the trig rectangle yet. Make sure the dot's nice and heavy. So draw one more unit circle if you haven't already in your notes. Because here's what I want you to do. Start on this mystery point. Go straight to the left, straight down, straight to the right, straight up. If you do it correctly, it should end where it begins. If your rectangle looks like a square, that's okay. This is not art class. Do you see that these are what I call mirror image points? The 4 corners are what we call quote-unquote mirror, I can spell, images. And I want you to tell me where they are. Now, let's just say this is like 1/2, comma I'm just gonna make, this is not gonna work, by the way. Let's just say this was like 2 comma 3. It isn't. But pretend it's 2 comma 3. Where would this be? Let's just try that. I'm gonna make up here, this is not a unit circle, it's bigger than a unit circle. But let's just say there's a point of, actually 3 comma 2. Right. Let's do a trig rectangle. Can anybody tell me where this is? If it's a perfect mirror image, go.
Negative 3 comma 2.
Negative 3 comma 2. See how I got that? 3 to the right, mirror image is 3 to the left. They're the same height, so they both have a height of positive 2. Where's this? Michael.
Negative 3,
Negative 3, negative 2. Pete, where's this?
that'd be 3, negative 2.
Correct. Do you see where these came from? Here are the numbers you used, and then you just made them positive or negative depending on where you were. Do the same thing here. What is this? Polly, help me out on this one. What comma what? Use these. You're not going to give me numbers. You're going to give me formulas.
So it's gonna be negative cosine.
Yep. Of theta.
Cosine.
And then a regular sine of theta. Correct. Give me another one down here.
Negative cosine theta.
Uh-huh.
Negative sine theta.
Correct. I do the last one. That's free.
And then cosine theta. Negative.
Negative what?
Cosine.
Negative sine of theta. Good. That's the trig rectangle. Put that in your notes. You'll need to know the 4 trig shapes on the test and all their parts. How many parts does the 30, 60, 90 triangle have? Well, technically 6. The 3 angles, which are easy, and the 3 sides. The second one is the 45, 90 degree triangle. 1, 1 radical 2. The unit circle has 4 parts. Center 0, 0, radius of 1, angle theta underneath, and cosine of theta, comma sine of theta. The trig rectangle recopies the unit circle and draws the rectangle with these 4 corner points. This is going to be the main thing I'm looking for the trig rectangle. Where are these 4 points? Make sense? Right. Now, take out your worksheet, 7B-1. We're going to walk through a few of these problems. I think, has anybody done any work on this yet? Just a curiosity, a little bit? Okay. What I would like you to do is number 1. The sine of 330 degrees. Let's just start from the get-go. 330. Can somebody tell me where that is? Julius, you show me. Where's 330? What part of the circle? 4th quadrant, right. Let's draw it. And again, remember, you're going to be drawing lots and lots of these. I suppose you could draw one really, really big one, but that's, yeah. So 330, tell me exactly where to find it. Julius, yeah. So here's 0. How do you find 330? Yeah, 30 degrees down, 30 degrees backwards. It's right here. Can somebody tell me if theta is 330 degrees? By the way, please put this in your notes. There's a symbol I'd like you to be able to use. It's much shorter. Theta r. Please write this down. Theta r is short for the reference angle. Theta r means reference angle. Can anybody tell me what angle is the reference angle for 330? Yeah. 30. How do you get that?
Well, if you just go straight up, it's 30 from 0.
Yeah.
Push it the other way, and so we just do the rectangle.
If you did the rectangle, which corner do we want?
Upper right.
The upper right, the one in quadrant 1. So this is 30 degrees down. This must be 30 degrees up, which puts it at 30. So the reference angle is 30 degrees. One of the assignments this week I'm going to give you is going to be asking you, here's an angle, give me the reference angle. That's how you do it. Now, cosine of 330 degrees. Actually, no, sorry, the sine. I'm looking at the worksheet. First and foremost, what does sine mean on the unit circle? Sophie.
Up, down.
Up, down. Is 330 up or is it down?
Down.
Down. So what would that make our answer, positive or negative?
Negative.
Negative. Does everybody see that sine of 330 has to be negative something? Because it's down below. It's underneath 0. How far down? By the end of this week, I will give you a bit of a shortcut for doing this. But for right now, use the reference angle. What's the reference angle again, Sophie? For 330?
What do you mean by that?
Reference angle is the mirror image that's in the upper right hand corner. 30. Does everybody say that if you did the sine of 330, there's no direct way to do that? We have no clue. Can you find the sine of 30 though? Go for it. How can you find the sine of 30?
By the 36-degree triangle.
Go for it.
So do 1 over radical 3.
What's sine again?
Oh, sorry, 1 over 2.
Correct, 1 over 2. Translate what that means. You just found the sine of 30. What does that mean physically on this thing? What is sine?
It goes up 1/2.
Exactly. This is up 1/2 space. Does that help you find the sine here?
So you can negative 1/2.
Exactly. You have just finished the problem. Sine of 330 degrees is negative 1/2. Does that make sense? All right. Good news and bad news. I'm actually going to bump this homework another day, partially to get a few more notes, and partially because I want to give you a relatively fast shortcut tomorrow. Good news and bad news on that. I forgot if I did this with you in Algebra 2 or not. I don't think I did. I think we ran out of time. But there is a certain problem. You tell me whether you remember this or not. You probably don't. I drew a great big unit circle and marked every single common angle, all the multiples of 30, all the multiples of 45, all the multiples of 90. And then I went down the rows and I said, okay, you remember, did I do this with you? Okay, there's a company called nodding. Usually people look at me with a little more trauma in their eyes. Yeah, don't do it again, please. But if I pointed to 30 degrees and I said, okay, give me the sine. So I say like, Polly, what's the sine of 30? What would he say?
1/2.
Yeah, 1/2, exactly. And then I say, okay, Sophie, cosine.
80.
You can actually use this if you want.
Radical 3 over 2.
Radical 3 over 2. B, what's the tangent of 30? You can use this.
What is the radical 3 over 1?
That's the other way around. That'd be for 60.
30. Oh, would that be radical third 1 over radical 3?
1 over radical 3. And if you fixed it, it'd be radical 3 over 3. You just got the sine, the cosine, and the tangent. Now go over here. Philly Susham. What's the sine of 150?
1/2.
1/2. It's the exact same as here. No, what's the cosine? This was radical 3 over 2.
So that's negative radical 3?
Negative radical 3 over 2. Jack, what's that? Oh, for heaven's sake.
Pardon the interruption. This is Sophie Gunso. Please come back to the office with all of your things. Thank you.
Who'd you go? Oh, there's you. Okay. I'm glad you understood that. I was like, who's who, what? Okay. Anyway, so you just cut off the hot seat, by the way. Tangent. What was the tangent of 30 degrees, Jack Long? What's the tangent of 30?
Tangent is 1 over radical 3.
1 over radical 3.
Radical 3 over 3.
Radical 3 over 3. What's the tangent of 150?
Negative radical 3 over 3.
Right. You notice this was uphill radical 3 over 3? This is downhill radical 3 over 3. Negative. That's all you have to do. Michael, what is the sine of 210? What is sine on the inner circle? Well, I mean, what in general? Is it up, down, left, right, or slope? It's up, down. Is this up or is it down? You got it. Sine going up here is 1/2, 1/2, -1/2, -1/2. You've got 4 things for the price of 1. If you've got the sine of 30, you've also got the sine of 150, 210, and 330. Same thing for cosine. You have the cosine of 30, you have these 3 as well. If you have the tangent of 30, you have these 3 as well. That's part of the shortcut. The other part of the shortcut, which I'm going to drill you in tomorrow, is if you can memorize the possible fractions that you get. There are actually not very many. All the multiples of 30 will give you 2 fractions and only 2 fractions for sine and cosine. Let me show you. It could be 1/2 or radical 3/2, and that's it. If you have a multiple angle of 30 degrees, you'll never have a sine or cosine that's anything other than 1/2 or radical 3/2, positive or negative. They're all like that. So if you memorize those 2 fractions, make them plus minus, you can find any multiple of 30 sine or cosine ever. Make sense so far? We'll drill you more on that later. For now, go ahead and let your brains cool off. Again, homework 7B-1 is going to be due. It was going to be due tomorrow. It's going to be due Thursday. There's another worksheet I'm going to hand out later that's going to be due Friday. And that is all we have. We'll take a minute or so. Let your brain cells cool off, and we'll pray soon. And people listening at home, God bless, take care, stay well, or get well. Get well and then stay well. How's that? Talk to you later. Bye-bye.